Hello everyone, myself Dr. Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on normal distribution part 3. Let us recall the previous session. In the previous session, we have the normal distribution and discussed the actual formula and the standard normal variate Z, and then finding the areas using standard normal curve. Now today I am going to solve some problems on normal distribution. Now the first problem is, suppose the weights of 800 students are normally distributed with mean 140 and standard deviation 10 pounds. Again I repeat, suppose the weights of 800 male students are normally distributed with mean 140 and standard deviation 10 pounds. Now the question is to determine the number of students whose weights are between 138 and 148 pounds and more than 152 pounds. So here in the present problem we need to find the number of students whose weights are between 138 and 148 pounds. Similarly, the number of students whose weight is more than 152 pounds. So to find the number of students whose weight lies between the given values or more than the given value, first we need to find the probability of a student whose weight lies between 138 and 148. Similarly, the probability of a student whose weight is more than 152 pounds. So first we need to find the probabilities. Now here we apply the normal distribution as the given information is the mean is given 140. So the mu is 140. And standard deviation sigma is given 10 pounds. And we know that x denotes the normal variate and z denotes the standard normal variate and standard normal variate. And how can you transfer this x to z? So using the formula z equal to x minus mu by sigma, where mu is the mean and sigma is the standard deviation. In the present problem, it is given mu equal to 140. So x minus 140 by 10. And we need to calculate the number of students whose weights are between 138 and 148. So if x1 equal to 138, what is the value of Z1? That we need to calculate using this formula. Similarly, if x2 is 148 pounds, what is Z2? In the second problem, we need to calculate for 152. So x3 is 152, then what is Z3? So if you calculate these values of Z1, Z2, Z3 using the standard normal distribution table, we can find the required solution. So here we transform these values x1, x2, x3 to z1, z2, z3 using the formula z equal to x minus mu by sigma, where mu is 140 and sigma is 10. So by substituting this 138 here, 138 minus 140 by 10. So 138 minus 140, which gives a negative value. So it results as minus 0.2, and z2 148 minus 140 by 10. So which results as a positive value, we will get 0.8, and the last one 152 minus 140 by 10. So 152 minus 140, 12 by 10, so 1.2. So these are the values, corresponding values of Z. Now coming to the first question, we need to find the probability of x lies between 138 and 148. So 138 less than x less than or equal to 148, which is same as probability of, what are the corresponding values of z? Minus 0.2 and 0.8. So minus 0.2 less than z less than 0.8. So that implies, since it is a continuous probability distribution, we use the integral notation, and we need to calculate the area from minus 0.2 to 0.8 under the normal curve. So integral f of z dz from minus 0.2 to 0.8. since 0 lies between negative and positive values, we can split this into two parts, minus 0.2 to 0 plus 0 to 0.8, and we know that the corresponding positive portion and negative portion are the same. So, this minus 0.2 to 0 is equal to 0 to 0.2 since the normal curve is symmetric, and 0 to 0.8. So, using the standard normal distribution table, we can calculate these two values. Now, using the standard normal distribution table, the area from 0 to 0.2 is given by 0.2881 and area from 0 to 0.8 is 0.0793, and adding these two values. So, this is the probability of a person's weight lies between 138 and 148 pounds. But it is required to for the number of persons having weight between 138 and 148 is given by probability of 138 less than or x less than or equal to 148 multiplied by total number of persons. So, 800. So, this is minus 0.3674 into 800, which results as 294 approximately. So, 294 persons are in between 138 and 148 pounds. Similarly, the second problem, we need to calculate more than 152 pounds. What is the probability of students whose weight is more than 152 pounds? So, probability of x is greater than 152 is to be calculated. So, to find this probability, we have to convert this x to z, then we use standard normal distribution table. And already we have converted this 152 into the standard normal variate value, which is 1.2. So, probability of z greater than 1.2. That means 1.2 to infinity, we need to calculate the area under the normal curve. And this is 1.2 to infinity means, as we have calculated the values in the previous session, this is z and this is f of z and the value is 1.2. So, this is 1.2. We need to calculate this region 1.2 to infinity. But using the standard normal table, we can calculate from 0 to some z only, and we know that 0 to infinity, the total that area is 0.5, and we can calculate this region using standard normal table. So, this region can be calculated using the standard normal table. So, our final answer is 0.5 from the total. If you subtract the area from 0 to 1.2, you will get the area from 1.2 to infinity. So, to find this region, let us subtract this shaded region from 0.5. So, from the normal distribution table, this value from 0 to 1.2 is given by, so the value from 0 to 1.2 is given by 0.3849 and 0.5 minus this is 0.1151. Hence, the number of students who have the weight greater than this 152 pounds is given by this 0.1151 multiplied by 800, because 800 is the total number of students. So, which results as 92. So, 92 students have the weight more than 152 pounds and 294 students have the weight in between 138 and 148. So, like this, using the standard normal distribution table, we can find the required probabilities. Now, coming to the second problem, find the mean and standard deviation of an examination in which grades 70 and 88 corresponds to minus 0.6 and 1.4 respectively. So, here in this question, it is required to find mean. What is the mean and standard deviation? So, we need to calculate the mean mu and standard deviation sigma. And what is the given data? The grades 70 and 88 corresponds to standard scores of minus 0.6 and 1.4. That means, given x equal to 70 or x1 equal to 70, x2 equal to 88. if x1 is 70, z1 is corresponding value of z is z1, which is minus 0.6, and z2 is 1.4. This is the given information in the problem. Now we need to calculate the mean and standard deviation. So here we use the standard normal variate formula. What is that? Z equal to x minus mu by sigma. So first one, that implies minus 0.6 is x is 70, mu is unknown, sigma is unknown. So from this 70 minus mu is minus 0.6 sigma. So 0.6 sigma minus mu is minus 70. So this minus 0.6 sigma comes to the left side, and then this 70 goes to right side. So mu minus 0.6 sigma is 70, equation number 1. Similarly, for this Z2 equal to, so similarly for Z2 equal to 1.4, 88 minus mu by sigma, which results as 88 minus mu equal to 1.4 sigma. So this is minus mu minus 1.4 sigma is 80 minus 88. So this comes to left side, and hence mu plus 1.4 sigma is 88. This is equation number 2. So by solving 1 and 2, because 1 and 2 are system of two equations in two unknowns, where the unknowns are mu and sigma. So by solving these two, we can determine the values of mu and sigma. Hence, by solving 1 and 2, we get mu equal to 75.4 and sigma equal to 9. So in such problems, sometimes the values of x will be given. So we convert x values to z, then we find the area under the normal curve using the standard normal distribution table. Sometimes x values and corresponding z values will be given, and we need to calculate the mean and standard deviation. Similarly, there are many other different problems in which x values, z values will be given. We need to calculate x in the reverse way, where mu and sigma will be given in the problem. So that means if the value of z is given, finding the probability. Similarly, if the probability is given in the reverse way, we need to calculate the values of z also. Now coming to the next problem, determine the minimum mark a student must get in order to receive an A grade if the top 10% of the students are awarded A grades in an examination where the mean mark is 72 and standard deviation is 9. So first thing is to read the question properly, try to understand the given question, write the given data, and what is the required one to calculate. So here we need to find the minimum mark a student must get in order to receive A grade. So to get A grade, what is the minimum mark a student should score? And what is the given data if the top 10% of the students are awarded A grades? So top 10% means where we can denote those students under the normal curve. So this is z, f of z, 0. Top 10% means top 10% lies on the right side tail. So here this is the 10%, 10% means 0.1, and we know that this half is 0.5, so this area will be 0.4. And to find the required one, first we need to calculate. Here this is some z1. So the area right to z1 is the area or probability right to z1 is 0.1. Then what is the value of z1? So if the area to the right of this z1 is 0.1, that means the area from 0 to z1 is 0.4. So from the standard normal table, we can calculate the corresponding value of z. So here this, let us write the in sentence form. The area from 0 to Z1 is 0.4. This is the area. So using the table we can find that Z1. So in the reverse way we have to calculate. So here try to find out a value which is very near to 0.4 in the standard normal distribution table. You can identify here 0.3944, 3962, 3997, 0.4015. So these two values are nearby 4, and it is very clear that this 0.3997 is very near to 0.4. So that's why we can consider this corresponding value of this area. So this is 1.2 here, 8. So 1.28. The area from 0 to 1.28 is almost 4. So let us use this value, 1.28. So we got that Z1. Now what is the next one? The students are awarded A grades in an examination where the mean mark is 72. So given mu equal to 72 and sigma is 9. So we have the formula Z equal to x minus mu by sigma. So from this, x minus mu is Z into sigma. So x is mu plus sigma Z. So what is mu? 72 plus 9 into 1.28. So if we calculate this, this gives the required value. So the result is 83.52, which is 84 approximately. So in order to score A grade, the student has to score 84 marks, minimum, at least 84 marks. So to receive A grade, the student has to score at least 84 marks or 83.52 marks. So this is another way of using the standard normal table. Using the area, we have calculated Z1. From that Z1, we calculated the normal variable value. So in today's session, we have solved some problems on normal distribution, and we continue the same in the next session also. We will meet in the next session.